So in this example of circuits, series and parallel, got a little bit more complication to it. Not much. I've just changed the resistors. They're not all the same. And instead of having the parallel part at the end, I had it right in the middle of the waterfalls. So it'd be like a waterfall of one, then two parallel waterfalls as the next set of falls, then the last set of last fall, I should say, would just be this one drop. And I've changed the voltage of the battery too. The voltage gain here is 12 volts. So I just did the calculations. To replace this parallel part of the circuit with one equivalent resistor, which I'll show on the circuit in a minute, I just have to use that trick again that we talked about before. 1 over Rp is equal to 1 over R2 plus 1 over R3. And if you go through and do that calculation, you get 1 over Rp is equal to 1 over 15 plus 1 over 20. And when you flip it, do the inverse. So instead of 1 over Rp, you want Rp over 1. You go 1 divided by 0.1167, and you get 8.57 ohms. And we want to find out what the current is through the whole circuit. So using Ohm's law again, current is equal to V over R, and the total voltage in the circuit is 12 volts. And the total resistance is R1 plus Rp plus R4. So R1 plus Rp plus R4, which is equal to 12 volts over, just going to get rid of the units because it just gets messy. R1 is 10 ohms plus 8.57 ohms plus 12 ohms. Go down and do the calculations. You end up getting 12 divided by 30.57, which is 0.3925 amps for the series circuit. So it's 0.3925, branches up into something and something that add up to 0.3925. When they come back together, it's 0.3925, 0.3925, and 0.3925 amps in that whole series circuit. And showing our results on the diagram, got 0.3925 amps all the way through. Now I've got I and R. I can actually calculate the V, because V is equal to I times R. So I can find the voltage loss here, and the voltage loss here as well. And just putting in the numbers. The voltage loss through resistor 1, called V1, is equal to I1 times R1. So that I1 is 0.3925 times the R1, which is 10. For V parallel, I had 0.3925, of course, times the R parallel, which is 8.57. And for resistor 4, it's 0.3925 times 12. And calculating them, I get 3.93 volts. That would be V1. 3.36 volts is VP, and 4.71 volts through resistor 4. If I add those three up, they'd better equal 12, and I'll just check it now. Oh, yes, they do. So the voltage loss here plus that one should equal a 12 volt that it started with, and it does. The last thing to do would be to find the current that was going through I2 through resistor number 2 and the current going through resistor number 3. And you would just use Ohm's law for that too. So I2 is equal to V2 over R2, and V2 would be whatever the V2 is, which is 3.36 volts, divided by the R2. And I3 would be the V3, which is also 3.36 volts, divided by R3. So that part's the same, but that part is whatever the value of R2 was. And same here, 3.36, that's the same, but divided by whatever the value of R3 was. And then you're done. You've found everything. Take care. Have a great week. See ya. Bye. Oh yes, one last important point. Your practice problem. This is the one to do for homework, and I'd like you to finish it, show all your work, and then take a picture of it and email it to me, okay? That will get you full marks. So here it is. Same circuit. 2 drops in parallel, followed by, in this case, one single drop and another single drop. Voltage gain this time is 6 volts. R1 is 22.2 ohms. R2 is 33.3 ohms. R3 is 11.1 ohms. And R4 is 15.5 ohms. And your questions are, as you probably would know, what is I1, I2, I3, and I4, and also what is V1, V2, V3, and V4. Okay, that is it. Take care. Have a good week. Bye.